Good morning, everyone. Vadim?
Yes.
Do you hear us? Welcome to our lesson. Today, we are going to talk about formal grammar subjects of formal grammar. So, first lesson about introduction to formal grammar. My name is Habibullah Madatov. I work at the UrSU State University as a head of the IT department. The main goal of subjects. So, as you know, formal grammar, every subject has scientific area that learn. So, formal grammar theory as a discipline is generally regarded as growing from the work of linguist Noam Chomsky 1950s, when he attempts to give the precise characterization of the structure of natural languages. His goal was define the syntax of languages using simple and What happened, Jamal?
I don't know.
Did you?
It's recording, yeah. Everything is recording, yeah.
Okay.
Yeah.
Okay. So our main goal is to describe rules of the grammar language as a formula. So we have to how to write it as a formula. What does formula mean in this subject? We introduce consequently in this next lesson. So definition. An alphabet is finite non-empty set of symbols. Symbols are assumed to be indivisible. Definition 2. A string of an alphabet sigma is a finite sequence of symbol of sigma. For example, if we have a set consists 2 elements, so we can, for example, A and B, so we can create symbols as A, only B, and together A and B, B and A, and etc. The number of symbols in the string X is called its length. For example, if X consists 2 elements as A and B, so length of the string is equal to 2. For example, as a string, we consider three elements, three consequent elements as A. So a length of this string is equal to 3. Did you catch me? It's convenient. So to introduce notation, such kind of sign or symbol for the empty string. It is epsilon in from Greek alphabet for the empty string, which contains no symbol at all. No symbol at all. The length of empty sign is 0, equal to 0. So definition 3. Let x equal to this one and y equal to this. Two strings, the concatenation of x and y, it means write sentence x string x and y together. So it means that concatenation of x and y for any string x epsilon x epsilon equal to x. Why? Because this one, so this sign means empty empty element or empty. So it is, yes, because of its because of empty position, empty sign, so it is equal to x. For any string x and integer n, we use n on the degree x on the degree n to denote the string formed by sequentially concatenation n copies of x. So, for example, as x, we take, for example, a, and as a n, if we take 3, so what does x x cube? What does mean? What does x cube mean? So it is consequently write 3 times a. Example. Sorry. Definition 4. The set of all string over an alphabet summa is denoted by summa with star, and the set of all non-empty string over summa is denoted by summa plus. What's the difference between summa star and summa plus? We include an empty string to this into this summa star, but here we consider such kind of string without any empty sign. The empty set of string is denoted by such kind of sign. Definition 5. For any alphabet, summa, and language over summa is a set of string over summa. The members of languages are also called the words of the language. So if we imagine if given such kind of set, not empty set, this one, and what does word mean from this alphabet? It means that non-empty sign that can be created from this alphabet. It means this is words. These are words of the language. Example: the set L1, for example, so, this one, and L2, this. Languages, these are two languages over the binary alphabet, 0 and 1. Why? Because this one is alphabet, L1 and L2 are languages. Here, L1 and L2 languages. But this set is alphabet of for the L1 and L2. And L1 has 3 words, only 3 words. L1, this set. So the language L1 consists from only 3 words. This one, first word is 0, 1, 1, 1, and etc. But L1 is finite set, finite language, but L2 is not finite language because it is not bordered set. So it is this language or this set is infinite set. For example, this word belong to L1, but 1, 1, this word is not belong to this set. Why? Because every word of the language 2 consists 0 and 1. On the place of n, we can put integer and we will take such kind of word begins with 0. So this word begins with 1. So it not belongs to language L2. So since language are just sets, standard set operations such as union, intersection, and complementation apply to languages. It is useful to introduce 2 more operations for languages: concatenation and clean closure. Clean, it means name of scientists. And operation also called as clean closure. Definition. Let L1 and L2 be two languages over summa. The concatenation of L1 and L2 denoted by together L1 and L2 between of these letters without any sign is a language C and Y. X belong to L1 and Y belong to L2. Definition 7. Let L be a language of a summa. Define L0, L on the degree 0 is empty. Yes, empty set, and L on the degree I equal to L on the degree I minus 1. What does it mean? Li, it means concatenation of L and L on the degree I minus 1. We here create a recurrent formula. The clean closure of L denoted by L on the degree star is a language. So the positive closure of L denoted by L on the degree plus is a language. So let's introduce with some examples. Example, what does, for example, L, such kind of a set consists 0 elements, 0 and 1, 0 and 1. So what does L on the degree 0 mean? It means sorry, here a little bit mistake here. Empty. This one is empty set. Yes, consists from epsilon. This set is consists from epsilon. Okay. What does L on the degree 1 is also consists epsilon 0 1. L on the degree 2, it means 1 and 1 concatenation of L1 and L1. So it means this set consists from epsilon 0 1 0 0 0 1 1 0 1 1 and etc. So another example that what's the difference between set with star and set with plus? Here we include And this empty sign also we include into this set. But here we on the degree plus we omit this sign. So regular expression and language. What does it mean? Let summa be an alphabet. The regular expression of summa and languages they represent are definite inductively as follows. The symbol empty set is a regular expression and represents the empty language. Here we have to understand that if we have some symbols and vice versa that here if given some signs we have to say languages of set of these signs. So regular expression we have to, we here inductively definite that inductively definite, yes, inductively definite language. What does regular expression mean? First, so the symbol empty set is a regular expression and represents the empty language. Second one, the symbol epsilon is a regular expression and represents the language whose only member is the empty string, namely epsilon. Third one, for each C belong to summa, C is a regular expression and represents the language C, whose only member is a string consisting of the single character C. If or and S are regular expression representing the language or and S, then or plus S or S and or with star are regular expressions that represent the languages or unit S or concatenation or S and or with star respectively. So what does grammar mean? Grammar, as you know, if we learn language is language consists from words and sentence, and together with words and sentence, we learn also rules relationship between words or between sentence. Rules of the sentence. It is in logic, in mathematical logic, it means predicate. And in order to learn languages, we our main goal is present our language as a formula. So formula consists from symbols and rules. Symbols, by means of symbols, we write all of the words and all of the sentence. And together with rule it means predicate, or rules also called in formal grammar also rules. So let's begin definition of grammar. A grammar is a quadruple these four signs, where summa is a finite non-empty set called the terminal alphabet. The element of summa are called the terminals. V is a finite non-empty set disjunct from summa. The element of V are called the non-terminals of or variables. S is a distinguished non-terminal called the start symbol. P is finite set of production or rules. Here, so in order to give, describe grammar, we have to first we have to give alphabet and non-terminal alphabet also, and here S we consider as an axiom, or P as a rule. We if we consider together these aspects as a these aspects, if we construct all of these subjects, so it is formula form of the grammar. Our main aim is also to create formula form of the grammar. So P is a finite set of production of the form. This one is, as you know, from discrete mathematics or mathematical logic, this formula is called from a B. Formula B follows from formula A, or alpha. Formula alpha, from formula alpha follows formula beta. Where alpha belong to the this one is also product, Descartes product of the sets, and B also belong to this set. Alpha is a string of terminal and non-terminals containing at least one non-terminal and B. And B is a string of terminals and non-terminals. Here, example. Let G1 consists from this sets. Here, alphabet consists from 0 and 1, and non-terminal set consists S, T, O, I, and S here axioms, and P as P we consider such kind of rules. So as we shall see, the grammar G1 can be used to describe the set 0 and 1. Here we will finish our lesson. Maybe if you have any question, you can ask, and in order to be good understand this lesson, we will continue in practice lesson. So thanks for attention.
Hello, it's Vadim Shulgin, and can I get that presentation or materials somehow?
Okay, thank you for your question. You can take my material on the Moodle course. As you know, I sent you all a link of the course, and I will put into this course my material also. Okay.
Okay, thank you.
This presentation also. Is there any question?
No, I have not.
Thank you very much. Jamal Big?
Yeah. Okay.
Please, you can continue our lesson.
Okay, so hello everybody again. I am Jamal Madatov, who will be the assistant teacher on this course, Formal Grammar, to the Professor Habibullah Madatov. So we will lead the course, Formal Grammar course, together. So I will be responsible for the tutorial part, the practical part. And so before starting, for the previous question, all the materials, presentation will be uploaded to the model-based system of this course. And also the tutorials and lectures will be pre-recorded and also will be uploaded to the model-based system. So you can watch, and if you have any question, you can watch twice, and you can learn everything from the model system of this course. Okay, so in the lecture part, you will get the theoretical knowledge, and in the tutorial part and the practical part, we will solve the problems, questions, interesting questions related to the lectures. So what else? Okay, so now we can start. Let me share my screen. Okay, so the first, the tutorial part may be a little bit shorter than the lectures because we will solve some problems and some of them will be homework for you. And let's start from the first exercise. So we have given this grammar. So VN, VT, PS, and this is already explained in the lecture. So where VN is the consist of S only, the S is the only non-terminal symbol. So VT consists of A and B. So P is the rules that is explained in the lecture. So S goes to S and S goes to B. So we have just two rules. So which language is generated by G? So we have to find the language that can be generated by the expressed grammar. So answer, we will repeat the application of the first production gives S goes to AS, and here we have first rule, S goes to AS, and we can repeat many times here. Instead of this AS, we can put again the same process, SAS. We can put instead of this AS, instead of this S, AS again. So in that case, we can put AS, AAS, AAS, and so on. So we can put whatever we want, a lot of A's. And at the end, we can conclude with B. So we can only finish this language with B. Without we cannot finish because this is infinite set. You see here AAS, SS, always S comes at the end. And once we use the second rule, then we can finish the language. So in that case, this language could be AB, first B, S is B here, the first, and then AB, AAB, here, AAAB, AAA, we can put as many B as we want. Sorry, A as we want. At the end, we will finish with B here. So a sentence generated by G is thus a string of A's followed by a single B. So this language that can be generated by the given grammar is the string of A's followed by a single B. A simple notation for the language LG is in that case A star B. So where A star is any string of A's of length greater or equal to 0. Y equal, if it's equal to 0, then the language would be just B. So the second rule is B. And A star means, already explained in the lecture. So this is the continuous string. So we can continue. We can put as many A's as we want, but finish with B here. So any questions related to first exercise? This is just introductory lessons to the formal grammar, the first lesson, and that's why the exercise also not so difficult. And from the next tutorial on, we will start with non-deterministic, deterministic, the languages. So the exercise will be also a little bit longer. So if no questions, we will start the next exercise. So exercise number 2. Let G becomes Vn, again the same, the statement, and where Vn is the set of S and Vt is AB, but the rules is a little bit different now. S goes to ASA and S goes to BSB, and S goes to AA and S goes to BB. Which language is generated by G? Again, the same things. The first two rules may be applied and repeated in any order. This will produce such derivation. So SAS, if you put AS again, we can, for example, if you put BSB here, the second rule, ABSBA, AB, BSB, for to S, we put BSB. And then this will produce again BSB, then here. Maybe we can, this time ASA. And the only way to derive a sentence from such string is by use of the third and fourth. So if you put AA, so finite set, and BB, so we can make the language. Otherwise, here is we have non-terminals, and so we cannot finish this sentence. So if we want to make a sentence, so we have to use the third or fourth language, fourth the rule. And this replaces S with AA or BB. In all cases, the result is a string of A's and B's followed by the same string in reverse order. So here would be so you know a palindrome string. So here is written you will get the string in reverse order. So you will have palindrome strings because here is our rules are the palindrome here. A as the palindrome means if you divide the sentence string into two parts, the first left part and right hand side of the string should be equal. In that case, we consider that string as a palindrome. So here you see in the middle is S and left hand side is A and right hand side also A is equal. That's why this is also palindrome. Here is also B and B. If we repeat this procedure many times, so we will have only AA SAA or AB BA, ABB BBA. So both parts will be the same. Okay, so the G is set to generate the language WWR, where WR represents the reflection of W. That is the palindrome. It should kind of a mirror, you know, the mirror of the left hand side. The right hand side is the mirror of the left hand side. So at home, if you want, you can also make another sentences. So you can use this because we have 4 rules, and here we produced. We tried to consider all the combination ASA and BSA, and then at the end we can finish with, for example, here if you put A, we can put AA or BB. In both cases, the right hand side will be reflection of the left hand side. Do you have any questions for the second exercise?
No.
Okay, I think everything is understandable, yes, because it's not so hard. This is the introductory exercise. Okay, so now the next exercise is we have given another grammar. So non-terminal is now consists of S, E, and F. So terminals are A, B, C, D, and our rules are S goes to E, S, F, and S goes to E, F, and E goes to A, B, F goes to A, C, D. So as you notice already from the previous exercise, so we can finish our sentence with AB once we put AB or CD. If we put to get the sentence or to produce a language, we have to use AB instead of E or CD instead of F. Otherwise, with these rules, we cannot finish because here is also non-terminal. So the answers, by applying the first production of P, ESF, n-1 times, we obtain the strings E, n-1, S, F, n-1. So if we put ESF n-1 times, so we will get n-1 E and n-1 F. As you already understood from the previous example, if you put n times from here, if you put here ASA, this rule to this place many times, n times, for example, we will get n times A on the left hand side and n times A on the right hand side. This is also the similar. So n-1 times E, n-1 times F, followed by, in the middle, S. The exponent indicates the number of successive occurrences of the element. By then using the second production, EF, production once, we obtain E n times F n times, because so far, by using EF, here we don't have the S, that's a non-terminal S, so we don't need, if we use the second production here, we don't need to continue with S, because we don't have any more S. And so far, we have n-1 E on the left-hand side, n-1 F on the right-hand side, or in the middle, we have S. So in the middle, if you put EF, so we will have left-hand side n times E, and on the right-hand side as well, n times F. And we don't have any more S. So using one of these, the two formula, we can conclude and we can get the sentence. So all the E's are replaced by AB, and here we replace all the E's with AB and all the F's with CD. The resulting string consists of n AB pairs followed by n CD pairs. So AB, 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 n times AB strings, and followed by n times CD, 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 because we can only replace E with AB and F with CD. That's why our sentence would produce only the strings of ABs on the first left-hand side and followed by CDs on the right-hand side. The language LG consists of all the sentences of the form ABN and CDN. ABN followed by CDN, n times. If n is equal to 3, then AB, 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 CD, CD, CD. and where n is greater or equal to 1. In this example, A alternates with B and C with D in the sentence of LG. It is possible to modify the grammar in such a way that the terminal elements will be neatly grouped in the sentence of L. First all A's, then all B's, etc. This will be the case in the following example. So here, the example number 4. So first of all, do you have any questions here related to sort exercise? The exercise is somehow connected to each other, starting with easy and then a little bit difficult, then it goes to it gets more difficult. So if you have any questions, please ask. No?
No.
Okay, so we can continue. Example, the exercise number 4, 1.4. So language AN, BN, CN, DN, obtained in the previous example, where N is greater or equal to 1, is generated by the grammar in the following example. So consists of the following production: S, E, S, F, yeah, this is the, and F is CD, and BC goes to BE, S goes to EF. These two are from the previous example. As you notice, BA goes to AB, BB goes to BB, and E goes to AB, DC goes to CD, and we have 9 productions. So I hope you understand the goal of the today tutorial. So now at home also you can repeat, and you can make, you can solve all this exercise. The first 4 production are essentially the same as those of example 1.3 at the above. They produce strings of the form ABN and CDN, where n is equal to, if we here repeat the procedure, as you understand, first, second, third rule from the previous example, if we put many times S to its place, we will use n times E. For example, if we put n minus 1 time, n minus 1 time E, n minus 1 time F. And then if we put EF instead of S, then n times E, n times F. And then if we put AB instead of E, then we will get n times AB, and instead of F, where is F? So F is CD. If we put CD instead of F, then we will get n times CD here. N times AB, N, and n times CDN. So then we will check now B and C. So here we have B, here we have B, here we have B and C's. CD. Here we have CD. And the other 5 productions serve in the further grouping of the elements. By means of the production 5, one can replace a string ABA, BAB. If we apply BA with AB. of arbitrary lengths by a string of A's followed by a string of B's. So here BA goes to AB, as you see. If we repeat this procedure many times, we start with A, and then as you understand, AB, 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 AB. It continues AB, 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 and we will start not from A, and from B. BA, 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 BA. At the end, we will have B. So instead of BA, we will use AB. And production 6 acts similarly with respect to CD, 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 because this is also the similar with the number 5 sequences. We must now see to it, and the further rewriting in terminal symbols is possible only when these arrangements have in fact been performed. So this is the purpose of the rules 7 through 9. So 7 to 9. And rule 7 serves to replace the pair BC in the center of the string with terminal elements, but it can be applied only if B and C are found in the right place, in the center of the string. And by means of production 8, the variable B are replaced by the terminal symbol B, on condition that each B is located directly to the left of a B. The process can be completed only when all the B's are already in the correct position. Finally, production 9 acts similarly in the right-hand half of the string. The result is a string of the desired form A n times B n times C n times and D n times. Sentence of the other forms cannot be generated by this grammar. So the goal was here. We see here that we produced AB n times and CD n times on the number exercise, number 3. And then goal was, our goal was to produce this production to make the language as A, n times A, n times B, n times C, n times D. So with this production, we can achieve that goal. So n times A, n times B, n times C, and n times D. So I explained in general now, and at home, you will finish this by deeper analysis. So you can finish this. This will be also, to finish this example, will be at home. So here is, I explained the main the main idea to make the language. So you will, at home, you will do this till the end for each step. And next one is the last one, exercise number 5. It is possible to write a still more compact grammar for language. And this is also exercise number 5 is connected with exercise number 4. So n times A, n times B, n times C, and n times D, namely G is given. And P consists of the following productions. So S goes to ESF, again, second, ABCD. ABCD is non-terminal elements. So the third production is EA goes to AE, and first one, DF goes to FD, EB goes to ABB, and exercise number 6, the production number 6 is CF goes to CCD. So this will be, I will leave it for you to experiment. This will be also similar with exercise number 4. So this will be homework for you. And once you complete this exercise, you can submit it through eClassroom, and we will discuss it later in the next tutorial. So you will use again the same procedure. You will use, this is a little bit different. So you can use here E, F, instead of S, you will put A, B, C, D. And you have to think a little bit. So we will see. So we will discuss this exercise in the next tutorial once you complete. So that's the end of the lesson.
Thank you very much, Jamal. Is there any question?
Do you have any questions?
So thank you very much again. Once that Vadim Shulgin joined to our lesson, thank you very much. And another magister from Kazakhstan didn't take part in our lesson. So maybe next time he also will join our lesson. So if you know any question, thank you very much again, and see you on
next. To remind, and the unparticipated students can watch the pre-recorded videos on the model-based system of our course, so they can follow the course.
Okay.
For the today tutorial, and we can discuss the course on our Telegram group and also on the Moodle. So
thank you very much.
If you don't have questions, so I can finish the video. Okay. Bye bye.
See you.
See you.